And then we have the second question. We have to take the limit as x tends to 3 of 9 minus x squared divided by 3 minus x. Good. And then again, let's just do this by substitution to see if we'll actually have a real number as a result. So if we substitute 3 in place of x, that will be 3 squared, that is going to be 9. And then we're going to write 9 minus 9, that will be 0. Right? And then as x tends to 3, we're going to have 3 here, just by substitution. So 3 minus 3, that is 0. Okay, again, we're having an indeterminate form, right, which we do not want, so we need to do more work, right? Good. And that will be by factoring. Okay, so in the numerator, that's a quadratic expression, so we can factorize that, right? Good. But good enough, we can change that to a certain form. We call that difference of two squares. Now look at this 9, it's the same thing as 3 raised to power 2, right? And then minus x squared. So this is a perfect square and this is a perfect square. So we have difference of two perfect squares, alright? When we have that, this has a very nice, or a very standard expression of factors. Now let me give you in a general form. If you have a number a squared and a number b squared, then we can factorize this to get a minus b times a plus b. Good. So I'm just going to apply this there, alright, using 3 and x. Take note of that. So we're going to write this as the limit as x tends to 3 of, so 9 minus x squared is something as 3 squared minus x squared. Now this equation here tells us when we have a squared minus b squared, we say a minus b. That will be 3 minus x, alright? 3 minus x times a plus b. That will be 3 plus x. You know, we had a, b. So that will be 3 plus x. As the next factor, that is just the numerator. So we factorize that, right? So you take note of this whenever you have a difference of two squares. So the denominator now is 3 minus x. So the argument we made in while we were solving the last question, that as x approaches 3, x is not equal to 3, right? So that means that this is not 0 and this is not 0. Therefore, we can cancel out common factors. Now we are left with the limit as x tends to 3 of 3 plus x. And this is very nice because when we just substitute x equals to 3, or we plug in 3 in place of x, this just gives us 6. So this 6 right here is the limit of that second question. Good. Okay.